So I'm happy to introduce Pavithra Prabhakar, who is a program director in Computing and Communications Foundations, or the CCF division, within the Computer and Information Science and Engineering, or CISE, directorate at the NSF. She's on detail to the NSF from Kansas State University, where she is a professor of computer science and the Peggy and Gary Edwards Chair in Engineering. With that, I'll yield the floor to Pavithra.
All right, thank you. All right, so yeah, thanks for the introduction. And this is not going to be a traditional research talk. This talk is mainly focused on introducing and clarifying any questions that you have about programs at NSF that support and encourage research in the area of safe autonomy. All right, so I'm going to give, before I get started on the programs, so let's take a step back and look at what formal methods are. Broadly, we're looking at mathematical techniques that enable the design and analysis of systems with provable guarantees on their behaviors and functions. And when we mean systems, they could be models, they could be software or hardware systems. And the key here is to have provable guarantees and proofs for correctness of these systems. And here are some examples of what formal methods comprise of: abstract interpretation, model checking, theorem proving, automated decision procedures, constraint solving, mixed integer linear programming, all kinds of SAT solvers, SMT solvers, probabilistic model checking, statistical model checking. So it's a broad set of techniques that are included in this class of formal methods. And as you can see, it doesn't need to be an exact guarantee that you get out of systems. It could be a probabilistic or a statistical guarantee, but we would really like to get some kind of guarantee on the correct functioning of the system. That's sort of the focus. So why are formal methods important? Because we would like to understand system behaviors, and proofs are one way to understand whether the system is behaving correctly or not. And this gives us increased confidence on system design and implementation, and eliminate any unexpected behaviors or consequent catastrophes. We saw several of them in the earlier talks today. And I would argue that this is a must for safety critical systems. And given that I'm in the safe autonomy workshop, this is, for me, safety means you need to give some kind of guarantees. And formal methods are sort of the crux over there, whether we are looking at driverless cars or robotic surgery. Okay, so with that introduction, the rest of the talk is mainly about introducing programs at NSF, and I'll try to give a little bit of the introduction to the organization of NSF, so you get some context for where these programs are placed and what their motivation is. So NSF broadly has different directorates at the high level. You can sort of think of them as colleges in your universities. And one of the directorates is the Computing and Information Science and Engineering, which we often refer to as CISE. And CISE essentially supports research and education projects related to computing, communication, cyber infrastructure. So that's sort of most of computer science. And CISE itself has multiple divisions, and the divisions in turn have clusters. So the first class of programs that I would like to introduce is the core programs. So every cluster takes part in this core programs. And the link that you see at the bottom is the solicitation, which is a common solicitation for all the core programs in all of CISE. And in particular, I would like to talk about one of the clusters, which is where I'm involved with, the Software and Hardware Foundations program. So this program supports foundational research in design, verification, operation, and evaluation of computer and hardware systems. And one of the main areas here is formal and semi-formal methods for specification, modeling, development, and verification of both software and hardware systems. And it includes defining semantics, logics, abstraction, compositional, refinement-based, and probabilistic methods of both discrete as well as continuous systems. So the projects are supported on foundational algorithmic as well as tools. And in particular, proposals are sought in enhancing the applicability, usability, and efficiency of existing formal method techniques like abstract interpretation or model checking, but also we are interested in new formal methods that can tackle new and emerging areas like artificial intelligence and autonomous systems, which is where we are talking about today, as well as policy and regulatory compliance. So there are two classes of projects. One are small, which have a budget of about 600,000 with a duration of up to 3 years. So these programs currently do not have any deadlines, so you can submit your projects at any time. And these are typically the right ones for 1 or 2 PI kind of projects. Then there are medium projects, which are slightly larger and have a budget of 600,000 to 1.2 million and can be for a duration of up to 4 years. These do have a deadline, and the last one was in December. So the solicitation for this year will be out, and I encourage you all to look forward for that. And these are more collaborative projects. And one of the things that's important is to ensure that the collaborative contributions are greater than the sum of each of the individual projects. So it shouldn't be just a couple of small projects put together, but really there should be a collaborative aspect to it. So there is a limit on the number of proposals an individual can submit in any window of 12 months. That's a year long. An individual can participate as a PI, co-PI, or senior personnel on at most 2 proposals over all of the core programs. So I listed all of the core programs, and there's a cap of 2 proposals that one could submit to all of them in 1 year. And if you have questions, myself and Nina Amla are the Cognizant Program Officers, so feel free to get in touch with us. So the link over here has specific information on what topics are covered in software hardware foundations. And so I talked about formal methods, but there's other things that SHF covers, such as software engineering and so on. And the reason one needs to just understand this is to make sure you submit to the right place, so it gets reviewed in a proper manner. So I see some of you taking pictures. That's totally okay, but this is all publicly available information, and I'm happy to share the slides. So shoot me an email if you want any of this information. All right. So these are core programs that NSF supports. Then there are cross-divisional programs, which are supported by multiple divisions. So these are programs that are that span multiple divisions, and one of them that's particularly probably interesting to this community is the Formal Methods in the Field program. And the broad idea of this program is to bring together researchers working in the area of formal methods with researchers in other areas of computer science and promote the design of rigorous methodologies for design of correct systems. So formal methods for the purpose of this solicitation is broadly defined as principled approaches based on mathematics and logic to system modeling, specification, design, verification, and synthesis. And these are the field areas that are currently of interest: computer networks, distributed operating systems, embedded systems, human-centered computing, and machine learning. And here is some examples of the kind of topics that might fit in. And this is in no way exhaustive, but this is what I hooked up to sort of bring it to this audience here. So correctness of ROS and the interfaces, correctness of planning and navigation algorithms, probably with robot dynamics, correctness of human-robot interactions, ML components in robotics. So think about projects where you would want to give guarantees, but also you have a field area that you would want to impact through those guarantees. So broadly, there are 2 kinds of tracks into which you could submit. The first one is the traditional research proposals. So here we require 1 PI at least from the formal methods area and 1 PI from the field area. And it's important that the project makes fundamental advances in both formal methods and the field area. So it should not be just an application of formal methods to a field area, or it should not be the other way around. So you have to be developing some new formal methods, making advances in that, as well as having some intellectual merit in the field area that you're focusing on. And there has to be some bidirectional interaction between the two PIs. Okay, and the budget is about 750K for a duration of up to 4 years. The other class of proposals are transition to practice proposals, which are essentially support those kind of projects which want to bring a mature research method into tool development. And the budget is 100K for up to 18 months. So this is the link for the formal methods in the field program, and these do have a deadline. The next deadline will be February 15th in 2023. All right, so then there are multi-directorate programs, and I'm listing a couple of those because they might be interesting to the audience here. So the first one is the Cyber-Physical Systems, which is essentially referring to systems that have computation and physical elements. And this program encourages proposals that do core science in the cyber and physical intersection, and promotes both methods, tools, hardware and software components that are developed with this cross-cutting principles. And as you can see in the picture, the core does have safety, security, and verification. So if you're looking at safety or security aspects on formal methods, that's certainly in the realm of this program. And yeah, building dependable and high confidence is certainly a big interest in CPS. And again, there are three kinds of proposals. You could do small proposals, which focus on emerging new and innovative ideas, and have a budget of up to 500K for 3 years and no deadlines. Then there are mediums, which are multidisciplinary in nature and have a slightly larger budget of 500K to 1.2. And these have a duration up to 3 years and no deadlines. So there is no regularity in whether there are deadlines, what's the budget, and so on. So that is something you would have to look up in the solicitation to really be sure what is the one that you should be shooting for. Then there are frontiers, which are extremely large projects ranging from 1.2 million to 7 million for a period of 4 to 5 years. And these should really push the boundary of CPS well beyond what today's systems and capabilities are. And they have a deadline in June, so we are sort of approaching the deadline for this year. Okay, so the other program is the Secure and Trustworthy Cyberspace, where the broad goal is to achieve truly secure cyberspace, and that requires addressing challenges in scientific and engineering problems, but also human behaviors and choices. So this is really a large program that is cross-cutting multiple directorates from computer science, engineering, mathematical and physical sciences, social and behavioral economics, education and human resources, right? And there are core proposals, there are transition to practice kind of proposals, and there are also education proposals. And the core and transition to practice kind of proposals can be submitted either in small or in the medium category, and they have their own budgets and durations. So here is the list of different research areas of interest within this program. And you know, the formal methods is certainly there, but there is also other things. If you're looking at security of data science, ML or AI, that's certainly again in the realm of this, in the scope of this program. If you're looking at security of cyber physical systems, that's again there here. So this is a very large program focusing on security and privacy. So I'll just talk a little bit more about what formal methods focus areas are. So if you're looking at formal definitions, models, frameworks for security, privacy, and trust. So that's certainly here, security and privacy preserving compositions, design analysis, verification, and synthesis techniques, and topics like information flow, programming-based approaches, secure compilation, verification techniques for cryptography, and so on. So yes, I mean, if you're looking at projects related to, let's say, security of autonomous systems, this would certainly be a program to consider. All right, so the last one, I'll just briefly talk about because this was discussed more elaborately in the forum during the conference. So this is the foundational research in robotics. And the focus here is on projects that are really making advances in the area of robotics. So these projects need to have robot as the central entity, and the project at the end of the project, the robots need to gain some new or significantly improved capabilities. And robotics should be the intellectual merit. I mean, there could be other things, there could be formal methods and stuff, but if your project has robotics as the central theme, then this FRR is the program to go for. So these programs are unsolicited in the sense that they do not have deadlines or a fixed budget, but typically the budgets go between 150K to 250K per year for a duration of 3 to 4 years, but there is some flexibility there on what you do. And several of the programs I talked about also accept career proposals. So FRR is one of them, but yeah, I'm mostly that. Okay, FRR is one of them, but all the core programs accept career proposals. The CPS program accepts CPS, SAXI, FRR, all of them accept career proposals. So the best way to figure out where to submit is going through the solicitation, and if you have questions, reaching out to the cognizant program officers, because they will be able to clarify whether this is the right program or they might direct you to the right. And FRR also has the CRII and ERI proposals. These are early career programs for PIs from institutes which are not R1 and who don't have sufficient startup package given to them. All right, so here is the contact. So if you have questions, you could contact the robotics@nsf.gov. So with that, I think I'll stop. So this is a broad overview of some of the programs I thought might have intersection with the formal methods, the safety and autonomy kind of topics. And yeah, and happy to answer any questions, and also happy to get any feedback on the programs at NSF, either from this talk or any questions you have. Thank you.
Thanks for the description. My question is about the career proposals. Can you describe more of the trade-offs? So suppose I'm doing formal methods for autonomous CDS and robots. What are the trade-offs of submitting career under SHF or under CDS or FMITF?
So the formal methods in the field does not have a career program. So the core programs do have. CPS program has, SATC program has, and FRR has. And what you asked is a very good question. It is always good to check with the program officer, which is the right program. But let me give a brief answer for how you would go about selecting which is the right fit for you. So for instance, if your research project is making the main advance is in the area of formal methods, then software hardware foundations is the right place to go to. On the other hand, it's doing the main advances in the area of robotics, then FRR is certainly the place to go to. Now, if the advances are made in robotics, but it could be applied to any systems with continuous and discrete interactions, right? So if that is the field that's where your project is making the main impact, then you would go to CPS. Right? So that's, I hope that answered the question.
That makes sense.
Yeah.
Okay, great. Well, in the interest of time, let's thank the speaker one more time.